Okay, we're going to use this list of perfect squares. All right, perfect squares are square roots that equal whole numbers. Okay, so square root of 9 is 3, square root of 16 is 4, 25, etc. So we're going to use this set of perfect squares to reduce, all right, and simplify the square root of 32. So when I'm looking at my list, I see that the square root of 16, all right, goes into 32. So I can break this into 16 times 2, and we're allowed to split square roots. So it's still being multiplied. All right, just split it in 2, and then the square root of 16 is 4. The square root of 2 is a decimal. It's not a perfect square. So this just becomes 4 radical 2. Okay, same thing here. I'm going to look at my list, and I'm going to search for something that goes into 150. And I see that 25 works. Now I want to pick the largest number, the largest perfect square that goes into 150. And so, you know, if I look at the rest of the list, make sure none of these other ones go in there. So this breaks down into 25 times 5 times 6. Alright, then the square root of 25 times the square root of 6. The square root of 25 is 5. So this is 5 radical 6. And that's my answer. Third example. When we can look at this 5 as almost like a coefficient. This is, whenever it's sitting out front, it's 5 times the square root of 24. So 5 times, and I'm going to break 24 into a perfect square times a non-perfect square. I look at my list, and 4 is the largest perfect square that goes in there. So I break this into 4 times 6. Remember, this is all a big strand of multiplication. So this is really 5 times 2 times radical 6. So that's 10 radical 6. And that's my answer. That's simplified form. Okay, need a little more room here. Again, this is just a negative 6 times radical 242. Look at my list, and 121 times 2 gives me 242. 121 times 2 would make 242. The square root of 121 is just 11. Square root of 2 is a decimal, so I'm going to leave that there. So negative 6 times 11 times radical 2, end up with negative 66 radical 2.